Now we will have time for Q&A from speakers, and please use the chat space, and Charlie is going to help us to navigate the questions that we have. So please kind of see the questions that we have in the chat space. And I would like to ask everybody to right now to basically turn on your cameras, so then we can have everybody who is able to kind of activate their camera, so we can have the discussions and communications with the speakers and also those who are going to join us for those communications. So I'm trying to bring up my laptop. Okay, now I can see the things that we have. Charlie, do you want to kind of manage the questions and see the questions that are going to be asked? Charlie, are you with us right now? So I'm just wondering if Charlie is.
Yes, no, I am. I am very happy to do that. I've just lost the chat. So maybe Kate the first one, and I'll take over from you by the time I found it.
Sounds great. Sounds great. So you already, yeah, that is kind of the. I mean, it would be nice if people have questions, they can post the questions here. But I can start with a question from our speakers. In terms of when we talk about individualizations, one of the questions that people usually ask us when they design a trial is what would be the right control condition. As you can imagine, I mean, we always have limited resources, and the question is when you design a trial for when your active condition is individualized neuromodulation, what would be the sham, I mean, other than sham, but what are the other arms that you design for the study, and how you might be able to design the most optimum way to do that? And I know it's going to be depending on the question that you have, but what are the strategies that you have to define your control condition?
Yes, I guess I can take that briefly. It depends obviously what you're trying to prove, and so one control is the clinical gold standard, right, which would be TMS from scalp-based targeting. And so you could say, here's my optimal approach compared to scalp-based targeting approach. A slightly harder barrier to overcome would be, here's my individualized approach compared to a average group target approach where you hit the same MNI coordinate in everybody. And then an even harder barrier would be, here's my individualized E-field approach where I just rotate the coil compared to exactly the same site in that person, but not optimized based on E-fields. So I think you can make the control more and more rigorous, but that also creates a higher barrier for you to prove that your extra addition is adding value.
Yep. What are the other answers? I saw Andrada's notes regarding the challenge. Andra, do you want to share your kind of your own challenges right now?
Oh, I was writing a question for when we're ready for questions. I wasn't contributing to this quite yet. But I think the control conditions are so tricky because there's so much variability and so much there's a balance between variability and precision. So on the one hand, we want to be very precise with neurostimulation. On the other hand, we want our precision to lead to interventions that apply to a wide variety of patients and participants. So from that perspective, I think deviating a little bit from the kind of experimental neuroscientific approach where we have control groups that are very narrow, that do for really well-controlled experiments, and allowing more variability in our controls so that we show that it has applicability in everyday context. To me, that's more important. But that's how I think about it. Happy to talk about this question when we're ready for questions.
I just wanted to say that the question is it's a great question and something we struggled with recently. I think it's really important to do careful measurements. So for example, if you have the E fields, you can use that as a regressor. And then even in a clinical context, I mean, we've got hundreds of thousands of people going through RTMS every day, but because we had the imaging, we could look at variability in relationship to outcome. And so you have both sides of the coin. And of course, if you're doing, for example, TMS fMRI, you've got to control for the motor response and the pain and that sort of thing. But I think careful measurements of all the critical parameters can give you a little bit of the best of both worlds.
Charlie.
Great, thank you. So we have some great questions on the chat. So thank you, everybody, and do carry on posting them. So we have one from Kairana. I don't know if you are around and want to ask it yourself, or I can. So which is a question close to my heart, really, but I know what my answer is. I'd be very interested to hear what other people's are. Is we have a history of trying to get more and more focal with our techniques, and given the difficulties we're talking about,
So coming from the DBS field, I have a strong opinion on that. As you get more and more intense with your stimulation, precision starts to matter more and more. So if you're off by a millimeter in DBS, that can have a huge effect on your therapeutic benefit and on your side effects. In the field of psychiatry, you can go all the way to ECT, which is actually still more clinically effective than any of our TMS interventions and is very, very non-focal. You're causing a seizure. So I think it's a very valid question, but with ECT, we have more side effects. So I think in the end, there's a trade-off between non-focality, efficacy, and side effects. And so you can go non-focal if you don't know where the target is, potentially have good efficacy, but you're gonna have more side effects. I think as the precision of our therapeutic target improves, we should be able to get more precise with our treatment with higher efficacy and fewer side effects.
Yeah, no, I think that's very valid, but I think that's very valid. And I think we should consider that a lot of the things we've been talking about today are approaches that are fantastic, but are complicated, very expensive, require a lot of advanced imaging and various other things. And maybe they're going to make this difficult to apply around the world, right? And maybe that less focal approaches with more side effects will mean we can treat people in areas of the world that don't have ready access to very clever imaging techniques. And so I think there might well be a place, as you say, there might well be a place for both. If anyone wants to jump in, please do. Otherwise, I will.
I just want to thank you so much for putting in context. My question comes, I am a clinician, so we see a lot of patients with atrophy. So we found that when we go very focal, actually it does not work as well when we go, because some also brain tissue has been lost. So that's where the question came from. Yeah. Thank you for your input. And I think I'm afraid I put two questions there. Most of you talked about reductions in this function connectivity in depression. I don't do depression, but when we do functional connectivity in our patients, we do see that. And I was wondering how. I just can't think something that I was also wondering whether it's specific to our population, or is it something that you always find, or is it some kind of coincidence?
Mike, I guess, do you want to start to that one?
I'm sorry, I didn't really understand the question.
Sorry, is it always, in most talks there was reduction in functional connectivity? Is it something that, and most talks were on depression, so I was wondering whether it's something that you always find, or is there a normalization? Is either the very elevated functional connectivity becomes lower, or the lower becomes normal, or it's or not?
I think you're referring to the change in functional connectivity that occurs with a TMS intervention. And I think actually maybe Romain Duprat might be the best person to answer this rather than me.
Romain, are you here?
Yeah. Well, I think it's a very difficult question to answer. Yeah, in depression we do see reduction in functional connectivity. That's true, but like as most of the cases in TMS, the region you stimulate, the parameters you use, and the protocol you employ is going to change the outcome, and it's still very unknown. Like the effect varies so much from individual to individual. It's a very complicated question to answer right now.
Could I add something to that? So I think, so I study emotion regulation, not depression. And for us, there's underconnectivity, hypoconnectivity that we see between regulation, frontal regions and emotion centers. And what we want to do is enhance connectivity rather than inhibit connectivity. So I think it depends on what is dysfunctional in the circuit that you're looking at, and then figuring out how your neurostimulation intervention can remediate or normalize that particular dysfunction. And for depression, there's hyperconnectivity. For a ton of disorders, we see hyperconnectivity, but I don't think the goal is to always reduce hyperconnectivity. I think the goal is to remediate dysfunction.
It also depends of what functional connectivity you're talking about. What are you aiming to modulate? And yeah, it's a very complicated question.
Yeah, and I think I suspect, yeah, I mean, we don't work enough with RTMS, which is why I sort of bashed it to the experts in the room. But certainly with direct current stimulation and other approaches, you know, we can change the direction. We can increase connectivity, we can decrease connectivity depending on the parameters. What you want to do, I think, really, yeah, it's going to be dependent on the clinical context and the site and lots of complicated things. It's certainly not going to be an easy. So yes, I think the answer to the question is no. RTMS does not always cause a reduction in depression, and we might need a longer question and answer session to work out exactly what.
And I can just add a kind of a small piece to that in terms of, I mean, there are already some kind of published studies that people try to, for example, target the connectivity between DLPFC and nucleus accumbens. And they showed that, okay, I mean, they wanted to basically increase those connectivities. And I mean, there are definitely lots of different options on that. And meanwhile, we know that those kind of biomarkers or potential biomarkers, I mean, they are not always linear in their behavior. And sometimes the question is, okay, how much do you want to increase? Sometimes it's just, it goes to a kind of degree that is, I mean, the increase in connectivity would be helpful, but at that period of time, it would not be that much helpful. So we need to think about those things, not always in a linear way. So there might be some non-linear effects as well.
I just want to add to Hamad's point to it. I think there's a big danger of targeting a neuroimaging correlate or even trying to normalize a neuroimaging correlate. And resting state connectivity is just one example, but it could be hyperactivity, it could be hypoactivity. In the end, these biomarkers or neuroimaging correlates of the disease we're going after might be causal, but they might be compensatory. And so, you know, going after a change in connectivity is your goal. Again, I just exercise a little bit of caution there. Because as far as I know, we don't have any way to tell whether a change in connectivity is causal or compensatory or simply unrelated for a symptom that we want to treat.